because what I'm going to do is 1.5 times that base amount of 2,000. That's how you raise something by 50%. This is the something, in this example, 2,000. We add 1 to it to raise it, because you have to raise it by the percent, and you have to keep the original amount. 1 time multiplying something by the 1 keeps the original amount. Adding to that the 50% raises the original amount by 50%, and of course 1.5 times 2,000 is 3,000. So that's, when we think to ourselves 2,000 raises by 50%, we just do it in our heads. But it's important to know what we're doing in our heads, and that's what it is. It will serve you well in life to know that when you decrease something, you multiply it by 1 minus the amount of the decrease. When you increase something, you multiply it by 1 plus the amount of the increase. I hope I said that right. I said decrease and increase a lot, and I might have got myself tongue twisted, but I think I got it right. If not, you can hit rewind and send me an email about the error of my ways. It's very possible. Oh, let's see. That was number 7, and I've shifted my papers around. Let's see then. No, that was not number 7. That was number 11. That was number 11. Now we're on number 12. I don't know that this is worth writing. I'll write it. Okay, I'll write it. All right, fine. The real interest rate is 4%. The nominal interest rate is 6%. What is the anticipated rate of inflation? What do we use to answer this? I don't believe your author gives credit in the book, and I don't know why. It's called the Fischer Equation. The Fischer Equation, I definitely put in that video. Give me a second to get caught up erasing this. Maybe I'll just say it and try to write it quickly. The Fischer Equation is that one, the simple little thing where the nominal interest rate is equal to the real interest rate plus the rate of anticipated inflation. The nominal interest rate is equal to the real interest rate. That's the real return that the lender gets and that the borrower pays, plus the anticipated rate of inflation. That's the Fischer Equation, and this is too easy, right? The real interest rate is 4, so that's that. And we're given the real interest rate, and we're given the nominal interest rate. And that's 6. 4 plus what equals 6? This is what we didn't know. Must be 2. Or we could subtract 4 from 6 and get 2. we have 3 variables up there. We have 2 knowns and 1 unknown. And that's pretty simple, I hope. Number 13, currently the price index used to calculate the inflation rate is equal to 90. The general expectation throughout the economy is that next year its value will be 99. The current nominal interest rate is 12%. What is the real interest rate? So there's 2 parts to this question. Our Fischer equation here is the second part of the question. The first part of the question is sort of what we were doing with the previous question, where we just have to think about percent change a little bit. That's it. Because we have this price index going from 90 to 99. So what percent change must we be anticipating? How does something go from 90 to 99? What change makes 90 become 99? 90, I just had said on here, 1 plus of the increase times the base is the outcome. 1 plus what becomes that? I think most of us see in our heads that 99 is 10% more than 90. We increase 90 by 9 to get to 99. Let me see what happens. I think let's go ahead and work this through a little bit. Just humor me. You don't have any choice. I'm going to record it anyway. You do have a choice. You could hit fast forward. If I distribute this 90 through, let's see what I get. 90 plus 90x is equal to 99. Subtract 90 from both sides, right? This is out of our lives. 90x equals 99 over minus 90 equals 9. Divide both sides by this coefficient. X is equal to 9/90ths. 0.1 or 10%. So we could do it in our heads. With these numbers, we could do it in our heads. Most of us wouldn't do this, but it's good to know what we are doing in our heads because it accomplishes a couple things. It gives us the tools to answer things that might be harder questions. Like these could be numbers like 183 and 165. I need to know what to do if I have numbers like that. I'm not going to see it like I can see 9 across here. So that's nice. And also, I'm thinking that maybe it's building up a little bit of confidence in, oh, wow, I get what I'm doing in my algebra class now a little bit better because I'm seeing it applied to something that I can do in my head. I'm hoping. I don't know. Like I said, humor me. Or just hit fast forward. Whatever. I won't know. Number 15. Oh, wait, I didn't go back around. So, okay. I need to go to part B. I'm sorry, I skipped. I said this was a two-part thing. This was the first part. We got the anticipated inflation rate. I have it written here as a decimal. 0.1 is 10%. That's the anticipated rate of inflation. And then we were told, using this here, if this is 10%, we were told in this case that the nominal interest rate is 12%. So we're missing this blank. What plus 10 is 12? 2. So with an expected inflation rate of 10%, the banks will charge 12% so that they can make compensating them for risk and their costs and their expected defaults and so forth. They can make 2% by making that loan. That's their real return for the bank. And let me just, because I almost forgot something, let me make sure I'm not forgetting anything by moving on to the next question. Nope, it looks like that's everything. Okay. The next question, this is about the winners and losers from departures from expected inflation. Having this fresh in our minds might be helpful. Let's see. Suppose that in 2019 there is a sudden, unanticipated burst of inflation. Consider the situations faced by the following individuals: who gains and who loses. So this is useful to have up here, this piece, because if they anticipated 10% and they made loans for 12%, what if they were wrong in this projection? You know, because we don't know the future. We might anticipate here 10% and maybe it turns out to be something higher, but we've already contracted a nominal interest rate of 12% with the borrower as a bank. We've done that. So here we go. A homeowner whose wages will keep pace with inflation in 2019, but whose monthly mortgage payments to a savings bank will remain fixed. Well, if your wages are rising with this higher inflation, you know, that's pretty okay. You're keeping pace with the general level of price rise. But if you already contracted a fixed payment or a fixed interest rate with the bank for your mortgage, it's getting easier to make those payments because if you're fixed at a mortgage payment of $1,500 a month and there's high inflation and you're getting raises, even if they're nominal raises in the sense that other prices are rising, that $1,500 a month isn't rising, so you win. That benefits the borrower, but the lender loses. Benefits the borrower, but it hurts the lender. A borrower is also, in some contexts, called a debtor, and a lender is sometimes called a creditor. I think borrower and lender is clearer, and I think it's used more frequently, but those are synonyms. Just be aware of those because I'm not remembering what our author uses, particularly I'm thinking in the multiple choice questions. They might use those synonyms, okay? B, an apartment landlord who is guaranteed to his tenants that their monthly rent payments during 2019 will be the same as they were before. This is before the higher inflation. So these tenants are getting wage increases. They might be artificial in the sense that it's just inflation, but the rent is staying the same. Who's going to win? They are. Because the real percent of buying power of those rents that they have to pay is going down. Who got burned? The landlord got burned. So, C, a banker who made an auto loan that the auto buyer will repay at a fixed rate of interest during 2019. This is the same as A. If the fixed, that's this picture exactly. Could even be these numbers.